Okay, so everybody you should have triangles, 6 triangles that look like this, yes, that are reflections of each other. We're all good? You get the 2 yellow, the 2 pink, and the 2 green like this, yes? Okay, good. So we are going to start on the front, so you can kind of move the triangles out of your way. We're actually going to start over here first. I have to back up a little bit, quick little review, so that we understand what all this stuff is on here. This is going on page 100 when we're done. But remember, you could just tape it in instead of gluing it in so that you can remove it later if you want to. So this triangle right here, all we have is the 30 and the 60. What does this angle right here have to be? 90. Okay. Is this a special right triangle? Yes. Okay. So in geometry, when we did special right triangles, and we did them like a lot, we labeled them with S, 2S, and S squared to 3. Remember? So across from 30, that was our S, hypotenuse 2S, and then this is S times the square root of 3. So that way, it makes it a little bit easier to solve for pieces. But when we're thinking about this triangle on the unit circle, then it's going to have a specific value every time. Let's say that S is 1/2. Okay, if S is 1/2, and this is a right angle here, then your hypotenuse is what? 1. And this leg is what? Okay, 1/2 square root of 3. And if you write it as 1/2 square root of 3, that tells me you're about to multiply that, not that you've actually multiplied. So when you actually multiply them, what do you get? Good, square root of 3 over 2. So this is the square root of 3 over 2. All right, so does that make sense to you? So that's what the labels on your triangle, and on your little triangles, they're actually on the inside, just because obviously if you cut them, you lose your measurements. But that's what's going on there. The reason that these are here like this is so that we can get the quadrants written on them, so that when we flip over, we use them correctly. So even though they're shown here like reflections, the quadrants are actually flipped around. So like here, this one that looks like this, which that is, what color is your triangle that looks like this? Green. Okay, let's find our green triangles and match them up with this. So even though on the left, when you go around quadrant wise, that's really quadrant 2, but this triangle here, we're going to label it in here. This is quadrant 1, this is quadrant 2. So do the same thing right inside of your triangles. This is quadrant 1, and this is quadrant 2. Okay, so that's mainly going to help us when we get on the inside. Okay. Then take the yellow ones, so it looks like the next set. And here, same thing. This is quadrant 1, and this is quadrant 2. So do the same thing right inside your triangles, so we use them correctly when we get inside. Okay. Everybody okay with that? All right, so now let's look at the 45-45. And there went my tape. Then this right here has to be 90. Is this a special right triangle? Yes. And we labeled this L, L, L squared root of 2. Right. So on this one, we're going to make the hypotenuse 1. All right. We'll look at why they're all 1 in just a minute. Which means I got to come up with the legs. So it's not quite as obvious as the rest maybe, but we can figure out what it is, right? Hypotenuse is L squared root of 2. So if I say L squared root of 2 equals 1, then L equals what? What do I do to get L by itself? Divide by the square root of 2. So I get 1 over the square root of 2. What's wrong with that? You got to rationalize. You can't have the square root in the denominator. So L actually becomes what? Square root of 2 over 2. All right, got to know how to rationalize your denominators. So then that makes this the square root of 2 over 2, and this the square root of 2 over 2. Okay. Everybody okay with all that? So then we find our pink triangles that match up at the bottom. Go ahead and reflect them like so. Oh, maybe I should zoom out a little bit. And then this is quadrant 1, this is quadrant 2. Do the same thing inside the little pink triangles. Make sure they're turned the right way so it works when we get on the inside. Any questions at this point? That's total review just in labeling some triangles. Alrighty. So let's flip over to the inside. What we have here is our unit circle. This is what we filled in yesterday, so I mean this one's already filled in for us. And here are your degree measures and your radian measures, and we're going to take your green quadrant 1 triangle. Okay. Green quadrant 1 triangle. And you're going to place it on the circle. I'm going to zoom in to where we just see quadrant 1 right now. You're going to place it on the circle with that 30-degree angle at the vertex. This side of the triangle along the radius of the circle. And then your 60-degree angle should touch that point right there. Okay, everybody with me? Check your neighbor if you feel like they need to be checked on. Then you're going to take some tape. And you might want to take the tape. Not every table has more than one, so you have to share. But if you're having to share, then you can tear off a few pieces and maybe stick them on the plastic box. But you're just going to take one piece. Okay, it doesn't have to be a ginormous piece or anything. And make sure it's all lined up nicely here, where it fits all pretty. And then put a piece of tape right there, just one piece of tape right there to tape it down. I'm also going to go in here and put my right angle in my triangle because it's a right angle there. Now, we have ordered pairs here that we are now going to fill in. This is a unit circle, and remember this was like a really hard question the other day for some reason. If this is a unit circle, what is this ordered pair right here? It is not 0, 1, people. Are you really in pre-cal? All right. It is 1, 0. Good job. All right, we got that far. Whew. It's going to be a rough day, I can tell. Okay, so this is a 1, 0. Now, when I rotate around the circle, the radius remains the same all the way around the circle. We do know that too, right? Okay, so notice here that the hypotenuse of this triangle is 1. What does the hypotenuse represent right now? What does the hypotenuse of the triangle represent on the circle? The radius. Okay, and it's 1, so that makes sense, right? It's like this point went here, rotated around there, and there's my hypotenuse. So we have these side links here. We have the square root of 3 over 2 and the 1/2, because we've rotated 30 degrees. Okay? And so what does the square root of 3 over 2 represent on my circle? What do you think that represents? The coordinate of what? What does the square root of 3 over 2 represent? The x value at what degree? Is it all the x values? At 30, right? What's 30 in radians? Pi over 6. I'm going to put pi over 6 there too. So this is my x value. This ordered pair right here has some value, right? We know that the x value has to be less than 1, because this is at 1. When you have this little 30, 60, 90 triangle here, do you see how that is the x value? It's the square root of 3 over 2. Square root of 3 over 2. What is the y value? 1/2. Do you see how we get that? We have to go to the right square root of 3 over 2. We go up 1/2. Bam. There's our ordered pair. We good? Okay. So now I want you to take this and you're going to reflect it down. Okay. Now when you do, it gets a little wonky. We'll fix that in just a second. But before we fix that, I want to write on this so that we don't tape and then we can't write. We know that this is the right angle. Right? We know that this is 30 degrees or pi sixths. And then this is 60 degrees. Don't really care about the radians of that one right now. The hypotenuse is what? 1. Okay, so the hypotenuse is 1. The short leg is what? 1/2. And the long leg is square root of 3 over 2. Everybody good with that so far? So now that we've labeled that, when you pull this down, you see how I can like pull mine down a little bit and it's like crooked even though it's taped down. So you may need to, if it pulls down too far, like roll it back up. You kind of roll, roll it along the tape and make sure then it's actually where it needs to be. right? And then you're going to put a piece of tape on the back side as well, but just this one, because we're not like taping the triangle down where we can't move it. It's going just right here. And then I can reflect it. I can have it up here, and I can have it down here. And which quadrant is this? 4. Okay, so this is quadrant 4. I'll label that inside my triangle. Okay, so now, guess what? I can get this ordered pair right here, too. What's the x value for this ordered pair? Square root of 3 over 2. What's my y value? Negative 1/2. Good. The values on the triangle stay positive because it's a side length, but it has a negative y value because we should know that all the coordinates in this quadrant have positive x, negative y. We all good with that? Any questions? Because we know what the coordinates right here to get to this point, I have to go to the right this much and down this much. This length is square root of 3 over 2. This length is 1/2. Okay. All right, so what we would like to do is also take this triangle and reflect it in the y-axis. However, that's really hard to do when you just have a vertex there. I wasn't creative enough to come up with how to do that, so that's why we have a second triangle. Okay, so you can kind of pretend like it's the same triangle. In theory, you can use the same triangle, and we could have done that, and then you just keep the triangles, but I don't want anybody losing triangles because they fall out of stuff. I like this better. I always like it better when everything's taped down. So we're going to line this one up over here like we did the other one. Oh, you may also want to, I probably should have said this first, you may also want to go ahead and fold your paper so that it's folded and you don't have to worry about the crease later and your triangles being in the way. If it's already folded, you're less likely to tape something over the fold and then it'd be weird. Okay, so I'm going to put that down. I'm going to put one little piece of tape here. All right, so this right here, if I rotate from my, I know some of y'all are still taping, but I'm just going to talk. If I start from over here and I rotate around to this point, clearly I haven't gone 30 degrees, right? How far have I actually gone? 150, right? So this 30, though, what does the 30 represent? What kind of angle is it in this case? What's it called? The shortest way back to the x-axis. The reference angle. Good. So for this point, 30 is the reference angle. It's a rotation of either 150 or 5 pi sixths. Okay, that's where we are on the unit circle, but the reference angle is 30. Does that make sense to you? Now, this ordered pair right here. Let's think real hard. What's this ordered pair right here? Negative 1. Yay! Negative 1, 0. I'm so proud of y'all. Now, because this reference angle is 30 degrees and we have this little special right triangle right here, we can get the ordered pair for this point, right? What's the x value for this point? Negative 3 over 2. I'm sorry, negative square root of 3 over 2. Thank you. I was just seeing if you're paying attention. And then the y value is positive 1/2. Everybody okay with that? Now we're going to reflect this down, and before we tape, we're going to go ahead and label. This was my right angle. This is 30 degrees, or pi sixths. This is 60 degrees. And then I know that the hypotenuse is 1 because it's the radius. The long leg is square root of 3 over 2, and the short leg is 1/2. Once you have it labeled, it wants to flip up because it's taped, then flip it back down, kind of re-situate it if necessary. The tape on the other side should cooperate pretty well. And then put one little piece of tape there. And what quadrant am I in now? 3. So this is my quadrant 3 triangle. So my x value for this point is what? negative square root of 3 over 2. And what's the y value? Negative 1/2. So not only do we need to know our radian values at these points, we also, at these angles, we also need to know the ordered pairs. And if you look at this, why this thing is not cooperating with me. If you look at how this works, these 4 ordered pairs that we just filled in, the reference angle for all 4 of them is what? What's the reference angle? 30 for all of them, yes? If you look at the x and the y values, the signs are different, but the numbers themselves are the same, right? So just like with the radians, the first quadrant's all you really, really have to learn, and then the rest just comes from that if you understand the relationships. Okay, we good with that? Any questions? All right, so take your pink quadrant 1 triangle. Your pink quadrant 1 triangle. And you're going to set it right on top of your green one like this, with a 45-degree angle at the vertex. The other one should touch at that point. You should be right along the radius of that circle. And then you're going to take one piece of tape and tape it down. Don't worry, it's not going to affect your green one. This all works out pretty nicely. Like so. So how many of you last year in Algebra 2 were thinking, all this stuff she told us was so important in geometry, like we didn't use any of this, right? Because you didn't, and I know you didn't. But it's all going to come back, and this is like releasing my inner math nerds, because the unit circle is just a beautiful thing, because there is so much going on here that all kind of starts to pull everything together, like the special right triangles and the trig and all this stuff. It's very exciting. Okay, so I know y'all just can't contain your excitement, right? It's okay. You'll be fine. All right, so here we go. This is, we already knew this side lengths because that's old business, right? 45-degree angle. So even though it's in the first quadrant, it's still my reference angle. And so for this ordered pair, what's my x value? Square root of 2 over 2. What's my y value? Square root of 2 over 2. And I forgot to do my right angle. I'm going to draw in the right angle. I should have printed those on there. And then we are going to reflect that in the x-axis. When we do that, before we tape, let's go ahead and write. So this is 45. This is 45. And then my radius is 1, or my hypotenuse. This is the square root of 2 over 2. Square root of 2 over 2. And which quadrant am I in? 4. So I'll put quadrant 4 here. You totally can't even see that in orange. Okay. All right, so now I can find this ordered pair right here. My reference angle is 45. Let's go ahead and tape it. When you do that, you want to situate it back up there. And when you do this, what you're actually doing is taping the pink one to the green one, but that's okay. Again, it all works out just fine. It's like a little flip book, and it'll be just fine. But tape it so it doesn't move on you. X value for this ordered pair. Square root of 2 over 2. And then negative. Good. Okay. All right, so now our quadrant 2 triangle. Set that one down. Situate it. Oh my gosh, I dropped my tape again. I'm telling you, it's been a rough morning. Okay. All right, there we go. Mine's a little off. Hopefully they're cut right. I mean, I tried, but I know I'm not perfect. There were a couple that were wonky, but I left them out of the package. So, all right, got that. That took way more effort than necessary. So my x value. Well, what do you know about all of the ordered pairs in the second quadrant? All the x's are what? Every x value in the second quadrant. negative. And all the y values are positive. So this is a negative square root of 2 over 2, positive square root of 2 over 2. And then put my right angles on both of these. All right, so let's reflect it down and label that 45, 90, 45, 1, square root of 2 over 2, square root of 2 over 2. And this is the third quadrant. Oh, you can't even see mine. Well, that's okay. You should be able to label them anyway. So once I've done that, I'm going to fix it up here so I can tape it down. Again, I know this seems like it's a lot of effort, but I'm telling you this is something that you will want to hang on to and you are going to refer back to a lot. There's that. Third quadrant, ordered pairs. X values are always what? Negative. Y values are always negative. So negative square root of 2 over 2, negative square root of 2 over 2. Right. You got the hang of it? All right, so I'm not going to talk you through the next part, the yellow ones. I want you to get them on there. I mean, you can follow me if you want, but I think that you should be able to kind of think through it on your own. So I am going to do it up here. If you get lost or confused, let me know. All right, but start with your quadrant 1 angle. And make sure when you do that that the pink one's flipped up so that you put it right on top of it like so. Go ahead, you can get both triangles on there. Go ahead and fill in your ordered pairs. Just try and see if you can fill it all in on your own. And then I'll talk you through it and make sure it's all right. I almost taped my yellow one down without flipping my pink one up, so be careful. Don't do that. Check your progress here. And hopefully as you're doing this, you're recognizing patterns that can help you learn these a little quicker. just like anything else. Just root memorization, I mean, it is what it is. In some people's brains, that works beautifully. But if you truly understand the concept and how things are related, that's really what's going to get you to completely learn it and know it when you need it. And but you know, there's no harm in some cute little song or memory trick or whatever. They work. So, for instance, I might have told y'all this a couple years ago, but the Metro commercial, like before, I don't know if y'all even realize this, but back in the day, we didn't have like 10 area codes. It was all 713. And then then we had 281, then we had 832, and then now there's another one, I think. But before all that, you didn't have that. Metro had a commercial, and their phone number, I remember to this day, it's 635-4000, because their commercial was Dixie Drive Your Cows In, 635-4000. So I will remember that number for the rest of my life. So little cute things like that can help if you have them and they make sense, because, you know, if I ever need Metro, I know what the number is. But I'll have to figure out the area code, but I know what it is. But you also need, if you understand the concept, you can figure it out. Okay. So are we all good? We got these all filled in, right? Now we're still missing 2 ordered pairs. They're really, really hard ones. What is this one up here? 0, 1. Oh, we've got the hang of it now. And this one down here is 0, -1. Okay. Now, notice what's happening here, that if you only know the first quadrant, it's good, because then you just have to know how the signs work in quadrants, and I think we've got that down. When you've got the 30-degree angle here, which is pi 6ths, you get square root of 3 over 2, 1/2. And then 60, what is 60 as radians? Pi thirds. Okay, good. So pi over 3. It's 1/2 square root of 3 over 2. So all that happens is the x and y values change places. We'll look at why that's happening here in just a second. Okay. All right. Now, so we're going to take this. We've taken our unit circle. We have radians on it. We've put our special right triangles on it to get our ordered pairs. Now we're going to tie this to trig. Okay, so let's go. We talked quickly about the 6 trig ratios yesterday. We're only going to probably have time to talk through the first 3 today. But if I'm going to, so you remember what's your acronym for trig? SOHCAHTOA, right? That's your little memory trick, right? I mean, not really a trick. You still have to know how to do it, but it helps you remember how to set them up. So we're going to start with sine. So up here in the top right-hand corner, you don't have a lot of blank space, but we have some. We have enough to get what we need. We're going to talk about the sine of this. What is this circle with the line through it called? Theta. Okay, so the sine of theta. That's just our generic angle, right? So sine from SOHCAHTOA is what over what? Opposite over hypotenuse every single time. So this is opposite over hypotenuse every single time. So we're going to look at what's happening here. Look at this triangle. We've got 30 degrees, right? If I want the sine of 30, that is opposite over hypotenuse. You agree with that? Yeah, that's what it is, right? What is the side opposite of 30? 1/2. What does 1/2 represent on my unit circle at 30 degrees? The y value, right? Opposite, which is the y value, over what? The hypotenuse, which is 1. Does that make sense to you? You see how that works? It's the opposite, which is the y value, over the hypotenuse, which is 1. So we're going to draw in this here once I find my pin that I want. Oh, I should have told you, grab a ruler. There should be some rulers in your boxes. Grab one out of here. So I know you have this triangle right here, but I'm going to move the triangle, and then I'm going to just draw in that perpendicular side of that triangle. If you line your ruler up with, with these 2 points here, it'll make it perpendicular. Don't draw the whole thing. Well, I guess you could, it doesn't really matter, but I'm just dropping the perpendicular down to the x-axis here so that I can make it look semi-accurate. And what that represents, this right here is my y value. That's how I would get to this point. This is the sine of theta in my triangle. So back over here, it's opposite over hypotenuse. The opposite, which it was 1/2, but it is the y value for all of them, over 1. Well, what's y divided by 1? Y. So the sine of theta is y. That's going to be huge for you. Because not only do you need to know that 60 degrees is pi thirds, because you got to start thinking in radians, you also have to know what the sine of pi thirds is. What is, look at your unit circle. What's the sine of pi thirds? Square root of 3 over 2, right? You're at 60, that's pi thirds. The sine is the y value. Bam, that's it. There's no opposite over hypotenuse that you still have to know how to do that for other ones, but with your special angles, those are things you just got to know. And if you understand how the radians go on the circle, how the ordered pairs relate to each other, and that the y value is just the sine value, bam, your answers are right there in front of you. And you know it all if you know what's what and how the pieces work. We good with that? All right, so now let's go to the bottom left. Cosine of theta. From SOHCAHTOA, what is that? Adjacent over hypotenuse. Good. All right. So now when I come back over here and I look at my triangle, we'll just look at the one we drew. Not even my green one, because now I actually have a triangle. I didn't have a triangle a second ago. My angle right here, this angle is still 30, or pi sixths. The adjacent side to this, what is the adjacent side of this triangle on my unit circle? It's the x value, right? This is how I get to my x value. Over the hypotenuse, what's the hypotenuse? 1, because it's a unit circle. So this is adjacent over hypotenuse, which is your x value over 1. So back down here, oh my gosh, there goes my tape again. Goodness. That is equal to my x value over 1, which tells me then the cosine of theta is just x. Yes, sir. That's a good question. He said, is it for just the unit circle or all circles? Not all circles, because for all circles, the radius wouldn't be 1. So I would have to take the hypotenuse into account. Does that make sense to you? It would be the x value, whatever you have, divided by the length of the radius, is what it would be in that case. Does that make sense? So it's still the ratio that works out. It's still technically adjacent over hypotenuse, but it's not always just the x value, only if it's a unit circle. That's a very, very good question. Anything else? Okay, awesome. So back here, now if I write over my tape, it probably isn't going to do too well, so I'm going to have to write to the left here a little bit. So cosine of theta, that's this part of the triangle. So on the triangle, this is the cosine of theta, this is the sine of theta, and again, that's only when your hypotenuse is 1 on the unit circle. Okay, we good with that? So we've talked about sine, we've talked about cosine. What are we missing here? Tangent. Okay, so here this one gets just a tiny bit trickier, and you're going to have to take your ruler, and we're going to have to draw in a tangent line. So if you remember when we started talking about tangent lines, you're like, oh yeah, we did tangent with trig, and then when we used tangent lines, like it didn't relate at all. Told you it really does, we just don't make that connection in geometry. So we're going to draw in a line that is tangent to the circle at this point. Now tell me, it's really going to check your memory here. How is a tangent line related to the radius to the point of tangency? It's perpendicular. Good. So you have to draw it perpendicular, and you're going to have to kind of eyeball it and just do the best you can. You can kind of, I think the width of the ruler helps you line it up maybe with these 2 points up here and down there, so you can try and get it as perpendicular as possible. And when you do it, you're going to draw through some of your points and the stuff that you've written. That's fine. Just draw this tangent line, make it long, like so. Right? And we know when we draw a line that is tangent to the point, to the radius to the point of tangency, that we get a little right angle right there. So now, so that we can get a triangle out of this, we're going to just kind of use this same part right here. This right here that was the hypotenuse of that first triangle we were looking at, we're going to extend it just a little bit so that it touches our tangent line. So use your ruler there too. And I'm going to draw right through my square root of 3 probably, but it's fine. I can still read it. And I'm just going to extend it so I get a bigger triangle there. Everybody okay with that? Oh, no, just this one is fine. We only need it really on once. Okay. All right. So tell me, first of all, if I want tangent of theta, okay, and I'm going to start with this little pink triangle. I probably should have done it before we drew this in, but this little pink triangle first. And we're going to talk about the tangent of theta. From SOHCAHTOA, tangent is what over what? Opposite over adjacent. Good. Right. So here, if I'm just looking at my smaller triangle or even my green one, the opposite over the adjacent, the opposite here was my y value, right? And my adjacent is my what? X value. So the tangent of theta equals y over x. And even more importantly, what else can we represent y as here? Look on your top left. Y is also sine of theta. So the tangent of theta is equal to the sine of theta divided by what? Cosine of theta. There are times when we work through things that we need the tangent of theta to be the tangent of theta. And there's times where we're going to need the tangent of theta to be represented as the sine of theta over the cosine of theta. Because it's going to allow things to cancel out and for us to do certain things when we get to trig identities. So that's a very, very important relationship there. So one more little relationship I want to see if I can get out before we run out of time here. Now that I've drawn in this tangent line, because what we just talked about does not tell you why a tangent line is called a tangent line. But if I look at this here, and I think about the tangent of theta of this bigger triangle right here, this theta right here, so I'm going to write tangent of theta again, I'm writing a different color, tangent of theta, that's equal to, it's equal to the opposite over the adjacent, right? So we're going to name these points. This point right here that's actually going through my square root of 3, I'm going to call this point B, and I'm going to call this point A down here. So the length of that side is AB. I didn't want to throw like an X in there and really confuse you. Opposite, so this angle here, the opposite side of this bigger triangle is the length of AB. You agree with that? And the adjacent side, what's the length of this adjacent side? Don't overthink it. 1. Isn't that the radius of the circle? So it's the length of, it's AB over 1. So the tangent of theta is just the length of this segment right here that you get when you extend it out there. Does that make sense? So instead of even looking at it as a ratio, it's an actual length on a triangle. And these two triangles, I was going to ask you this question and not tell you, but we don't really have time for that. These two triangles here, do you know how they're related to each other? They're not congruent, so what do you think they are? Similar. And they're similar by angle. Remember I told you that was important too. These two angles here are congruent and they share that one. So those triangles are similar. So this is a length, which is cosine of theta. This is a length, which is sine of theta. This length here is the tangent of theta. There's also relationships on here for the secant, cosecant, which we'll have to look at tomorrow, but that's why I wore this shirt today. And I'm not going to wear it again tomorrow because that would just be weird. But I have a picture that I'll show you too, but how all the lengths of those ratios that we find are actually part of this. So we're not done with this. We're still going to write some more stuff on here tomorrow and look at some of the relationships. But I think we've gotten far enough today. So I just want you to make sure you don't lose this or destroy it. If you want to tape it into your ISN, you can. If you want to glue it in, you can do that too. I was going to give you an assignment today, but I've just changed my mind. Did I just make your day? No, it's not thick at all. It's actually good practice. But the bell rang. It's all good. I'll give it to you tomorrow. But you are going to have a quick quiz tomorrow.